because,
Professor?
yep.
I don't know if you could do this later, and sorry if you can't hear me really well. But there was a question on the quiz that I was a little confused about. I was wondering if you could go over it.
Which one?
Number 4.
Number 4?
Yes, I could type it in the chat if you want.
So it's like converting from MIPS code to machine code.
Yes, but I was unfamiliar with just numbers being there. I usually recognize like $T0, but never like a $sign and a number. I wasn't really sure how to figure that out or if it works the same way. I don't know. I guess I felt really confused with that problem.
It's pretty simple. So if you look at the reference sheet, just use that and convert from there. I mean, it's pretty simple.
But it doesn't have a registered name, I believe.
$6 is the register 6. It's if you look at the reference sheet.
Okay.
And one thing I noticed that some students, they did not convert it to hexadecimal. I still give them point. I didn't get that point for that, but it should go, 1 point should be lost for that. So this was quiz 1, isn't it? Quiz 1. Where is this? No. Mm-hmm. Where's my quiz 1? Oh no, I didn't figure out the question. Let me download from there. From quiz. So question 4. So what was the difficulty? Like $8, $6, $10? Rita? The Rita was?
Oh, yes.
Yeah. So what is the like misunderstanding, or do you understand?
Okay, so whenever I do problems like this, I usually go to the part where it says on the reference sheet.
Yeah.
I go to register, name, number, use, call, convention, that little chart there. So then I'll look for the name or the number, whatever I need. But in there, there's no like just $10 or $8. So I don't know. I didn't know if that was something different, or I don't know, because over here I just see $V0 or $A0. So there was usually a letter in it. So I think that's what threw me off.
Let me look at the reference sheet again and open up and share it and see. I don't have it. Yeah, let's see. It's in the slides as well, I think. MIPS screen sheet. Let's share it. Okay. If you go down here.
Yeah,
Oh, so you don't have a dollar here. That's why I was wondering, like, what is that? It says 8 is here, in here, 6, 8, 10, all is here. And this. So that's corresponding registers of this. But we're not looking for registers, we're looking for just numbers. So you can just convert them into binary, and then you just make it hexadecimal. That's all. It's simpler than you think.
Okay. So, okay, I get it now.
Yeah, so 6, 10, 8 is here. So 6 is here, and 8, 10 is here in this line. The dollar T0, the register T0, T7, so 8 to 15. So you figure out. Basically, you don't have to worry about it. It's just to convert them into binary and then do hexadecimal. It's a lot simpler.
Okay. All right. Thank you.
All right. So in the final, I mean, it's not final, it's kind of final actually. Midterm is kind of final because it's final for these 6 chapters. So it's kind of final. So we'll have 10 questions, but I think 2 will be just descriptive short questions. So you don't have to spend too much time on that. Like this. What is high level language? So here you see that what's your name? Rita? See in these slides?
Yes.
Add $2, $4, $10. Same thing. I just put similar. Instead of add, I put so.
Oh, I see. Okay. I need to revisit that slide. Thank you.
Yeah, simple example. So it's just convert them in binary and then.
Yeah, that's what I thought. You just convert them to binary. You don't really need the register, since if it's a register, then we would just basically look at the character A and then that. But because there isn't, just do binary.
Yeah, it's given. It's straight away is given to you instead of going through those registers. That's fine. I mean, it's kind of confusing a little bit. That's okay. So you got that what I mean here. Just let's say pick up from here. Just put so instead of add. It's an example. That's okay. So so the couple of questions. So if you have 10 questions, so 2 of them will be like short questions. Like those. What is high level language or what is low level language? Something like those. Line. What is GPU? Whatever. So this and the other 8 will be like similar that we already have done 4 of them in this midterm. So I think you may need to speed up, but I'll pick up easy one that you can do quickly. Okay.
Oh, sorry, excuse me, Professor.
Yeah.
Can you give me permission to record through the participants list?
Sure. Where was it in the participant thing?
Yeah, you go to participants, and then you're going to find my name, Dylan Suin, and then you're going to click on the more button, and you're going to click permission to record.
Okay. Permission. Allow to record local files. I think that's the one. You see it now?
Yeah, thank you very much.
Okay, no problem. So so among these 10 questions, 2 will be like the short questions, and 8 will be like your conversion stuff. But I'll pick up the easy one that I can do within this time frame. You have 75 minutes. So not too small. I mean, it's still a long time, but sometimes it takes longer to do this stuff. But get familiar with the sheet, the reference sheet, the green sheet. It's very important that you thorough with that green sheet because you need to use that a lot. What is the green sheet? That's the question. Green sheet should be somewhere. No. Lost there. All right, so don't worry about the green sheet. Like we'll talk about it later. So first, to go through this, so you are familiar with this. We've been through a couple of times already. And any question, any particular question, then I should pay attention here from your point of view. from my point of view, is important is here, these slides. The difference between high-level language and low-level language or machine language. See, the machine language and assembly language are different. They're not the same. Machine language is just zeros and ones, but assembly language uses symbols. So the MIPS is one of the assembly language we're learning, simpler one. So that's the thing. And difference between high level and low level, main is high level is English-like, and assembly is use symbols. That's the one main difference. Another main difference is the high level language is portable across multiple platforms, but low level language is very specific to a CPU, design of the architecture of the CPU. So that's important from the slides. So take notes. Why study machine structure? Because we need them for compiler development. We need this knowledge, and also low-level operating system code, and also performance critical code like games, multimedia, audio. You need to learn about machine structure more, and also the graphics processor development. If you want to develop a graphic processor, because for the graphics you need more power, isn't it, for game and stuff, and for multi-core development as well. So that's why we need to study computer architecture or machine structure, the same thing. And then important complex instruction set computers and reduced instruction set computers too, CISC and RISCs, and their examples. Very important. Remember that. And personal computers, servers, supercomputers. We are very familiar with this. I shouldn't have any question from those, but some question from here, the Moore's law, and we already have that in the quiz. And what else from here? Not much. Then under the device, input device, output device, some examples should be familiar to you and okay to give any good examples for input device, output device, and integrated circuit, and central processing unit, data path control. So you have definition for all this. Memory, dynamic, random access memory, we had in the quiz as well. Cache, what is cache? And static random access memory. Cache is what? Small, fast memory. And then example of volatile memory and non-volatile memory. Okay, that's important to understand and remember. And nothing for me. So that's it, only a few things from that chapter. Okay. Now, next chapter, chapter 1. Now this. The integer representation in computer systems. The unsigned representation, signed representation, signed binary and hexadecimal arithmetic. So you're very familiar with this, how to convert from decimal to binary now. And binary to decimal is more simpler if you use chart. And what else? And chart is, you can create a chart like this, like 1, 2, 4, 16, 32, 64, 128, 256, 512, 1024, 2 to the power 10. If you need that long table. Binary, decimal, and hexadecimal, you know that only hexadecimal number starts from the 0 to 9 is same. Only the 10, 11, 12, 15 is A, B, C, D, E, F. So that's the difference. And the binary, you already know how to convert this. It's 1, 0, 0, 0, 1, 4 bits, 0, 1, 0, 0, 4, 1, 0, 1 is 5, like that. 1, 1, 1, 1, 15 is F. So let's practice all this conversion. There will be two methods also. A lot of people did that in the quiz, that's fine. And then conversion from hexadecimal to decimal, or even hexadecimal to binary is very simple, the binary one. You just put F, what is the binary F is 1111, 8, what is 8 is 1000, 3, what 3 is 0101. So that will be your binary for this 3 hexadecimal number. But then converting from hexadecimal to decimal, we need to use this 16 to the power 0 times first from the right plus 16 to the power 1, second number times that, and third number is 16 to the power 2 times the third number. And you work it out, that will be your decimal number for that particular in decimal from hexadecimal. All right, so I'm gonna put this. And you also can divide by 16. You can do that method for hexadecimal to decimal to hexadecimal, or you can use this chart, like divide the number in such a way that you can use the chart of hexadecimal. You can use that. Either way, you just convert it. And this is from hexadecimal to binary, as I mentioned the earlier one. 3 is 0011, and then you have B is 11, so it's 1011, and 5 is 0101, 0101. So put it together, that's your binary number for that hexadecimal. Pretty simple. Anyone has any issue with this conversion methods? Octal number, I will not ask any question in octal. Don't worry too much about it. It's just divide by 8 or base 8. You can create table for 8 and that kind of stuff. But now the unsigned integer addition for binary addition. So you need to learn this, you need to practice this as well. You may have a simpler one to do in binary addition or hexadecimal addition. Anyone has any question with that? Please feel free to ask now. An example here, are you clear with this? This one, hexadecimal one, E plus 2. So E is what? A, B, C, D, E. That's 10, 11, 12, 13, 14. 14 plus 2 is 16. So 16 is a hexadecimal. If you have a 16 number, you put 0 there, but 16 plus 0 is 0. So I take the 16 as a carry, so you put 1 there, and then we add that to this D. What D here, A, B, C, D is 13. So 13 plus 1 is 14 plus 8. So 14 plus 8 is 22. So 22 is 16 plus 6. So you put 6 there and carry 1. And then you add that 1 to 3, so it's 4. 7 plus 4 is 11. 11 is B. So that's how it becomes. That is our B60 hexadecimal addition. Just to practice some of this, and you may have question. Unsigned integer subtraction, I'll not ask you in this question, so I'll just drop this off for midterm. The sign magnitude and one's complement, two's complement. It's very simple. So sign magnitude is the whatever binary number you are given, you just says is sign magnitude number. Then the first number, first digit from the left actually is a sign digit. So meaning that if you have a 0, that's a positive number. If you have 1, that's a negative number. And then the rest you calculate if they ask you to convert to a decimal or something. So the first one will be just sign. So that's sign magnitude. And then one's complement is what? One's complement is just the number, and you inverse that number. If we have 0011, then 1100 will be the one's complement of that number. Two's complement number is that you add 1 to one's complement number, and that becomes the two's complement of the original number. So that's what it is. So rules are given here, and follow the rules, and you should be fine with that. And that's it. I will not ask any complicated question from two's complement or anything like that, okay? You can just, those. And use complement addition, no, will not be in the test. But you may have short question, what is overflow? Overflow is that if that number cannot fit into that whatever digit you given, and that's the overflow. So in choose complement addition, you can throw that overflow. Sum of two negative numbers cannot give you negative results. Overflow or third. So just ignore that overflow number, that's all it is. So definition is here there. So overflow is an error condition in which the result of a computation does not fit into the available number of bits. So if you have question like what is overflow, then you have to put this definition there. Overflow is an error condition in which the result of a computation does not fit into the available number of bits. If you're working with 8 bits number, if your total sum or addition becomes 9 digit, then 1 digit for the last one, you just ignore it. And probably that's about it from this chapter. Yeah, that's it. That's your preparation. From this chapter, then third. Pointers and errors. I think we'll not have any question in pointers or errors in the midterm. So don't worry about this chapter at all, actually. But this functions and the stack pointer, you may have a question or maybe a short question or something like that. That the stack use last in first out data structure, because if you want to add some item, you have to add from the top. So you push add an item to top of the stack, and then when you try to take one out, then you have to remove an item from top of the stack as well. So adding and deleting will be from the top, because that's a stack. You cannot go in a particular location. You have to go through first one, second one, third one, like that. You have to remove those first and then go to the bottom one. So push to add, pop to remove. So last in, first out. Whoever last in, you get a first out. So that's the LiPo model they use for the stack. And then the register 29 used for this stack point, $SP. And I will not ask any complicated question from here. So just, no question from the function. Just ignore that for the midterm. All right. Now the 5. 5 is the machine language. Instruction, operation, formatting, that's important. So we have 3 format, R format, I format, and J format. And we practice more for R and R format. So you have 32 bit. So opcode is 6 bit, RS5, RT5, RD5, and function code or extension opcode is 11 bits. So total 32 bits. That's the R format. So you did a lot of practice on R format, and you may have question for R format from MIPS code to machine code or machine code to MIPS code, kind of R format example. And this is how you deal with this. If you have a add operation and you have the 3 registers, 23, 22, 13, then you just convert them into binary and put it in RSRT, RD. So this is how you represent in the machine code. And then we have I format. This is the I format. Immediate. So you have opcode 6, RS5, RT5. and then 16-bit immediate. And an example here, ORI 2313. This is a hexadecimal number, that's a number, basically 9876. So put 9876, that's the number. And then RS and RT, you convert it. And this is for the opcode for ORI 001101. You get it from the reference sheet. Anyone have any question about the R format? I format? No? It's fine. So J format, see the load word is I format. And you have this RSRT and then a stack pointer, 16-bit here, 29. Okay, so you may get question from R format and I format and J format, and then BTA calculation. I'll not ask any question on this. BTA, the branch target address. This is the formula, address branch instruction plus 4 plus shift left 2 bits, and sign extension to 30 bits. So that's how you calculate the BTA, but you don't have to prepare for that. All right. For the J format, I'll not give you any J format. I think that's about it from the chapter. And the loop and all other functions will not be tested in it. So don't worry about any practice of the J format. J format. Just focus on R and I format. Then you have chapter 6. That's the digital logic basics. So I give you an assignment already. If you check it, it's a very simple one. Just drawing some of this and some short questions.
So that one, the assignment we need to draw in the copy, correct? Like in the notebook.
What is that?
The assignment that you give it to us, like about the and or stuff. We have to
Yeah,
do.
you just draw it in the piece of paper.
Oh, okay. I'll submit it today then.
Yeah, you just take a photo and just submit it.
Okay.
And you have 2 short questions. You need to study those questions and write it down too. From the book. Yeah. A very simple assignment I give you. Because you're preparing for the exam, the midterm. All right, so then okay, and share it. The combinational logic gates, register and the memory, flip-flop stuff. So just you may have one question from this, the logic gate. So not get, and, or, NAND, nor, XOR. You need to remember this output. If you have this input, what is the output for those combinations? Basically, here is 1, 2, 3, 4, 5, 6. There's a 6 table here, but to put it in 1, a 6 table for 2 inputs. And sometimes you have 3 inputs and draw these gates. So you learn it using that. Logisim, very simple to use. Wearing tools and all that on the left side. And you can drag and drop from the top as well. And you also can put equation or some kind of truth table as well. Then you're going to analyze can create table for you. Create the gate for you, the logic gate for you, logic design for you, build a circuit logic sim. So you can. So if you have a 3 input, then the result for the T0, T1, and Y will be like this. So you can actually implement it in the logic gate as well. And the logic sim has the analyze circuit feature. We test it, it worked. We'll do this automatically. So you go to menu, project, analyze circuit, then inputs, enter the name of the inputs, enter name of the outputs, enter the expression, and click on build circuit. And this will create a circuit for you. So then we have this simple adder circuit. So we have this 4 input and 3 output for the adder. And this is the truth table for that. It's given. So you just draw this circuit. We're given the truth table. And there's some selectors as well for the multiplexer. So you have this 2 input and then 1 selector. So a selector can stop you to picking one just, and then use this 1 to the output. So this is the multiplexer they call it. 2 input, but you use only 1 at a time. Whenever you like, whatever your pitch input you like. So using the selector. The selector will stop you selecting from 1. Create a multiplexer. You have 4 input, 1 output. And you have a selector as well. So some example and some truth table for the decoder. Then flip-flop. Flip-flop is as part of a combinational logics. Is a digital logic component that is a memory element. It can store information. That's the flip-flop is. And then D flip-flop. Several types, but we only focus on D. D flip-flop is like this. You have a enabler, you have a clock, and you have input, and you have 1 output. The stored bit can be read on the Q pin, output pin. So let's step up the flip. Clock. And then this 2 gigahertz is 2 times 10 to the power 9 cycles per second. 1 cycle is 0.5 times 10 to the power minus 9 seconds. And that is equal to 0.5 nanoseconds. That is 500 picoseconds. Pico, nano, and then cycle and hertz, gigahertz. Then we have D flip-flop. You don't have to worry about this too much. There's 4 input D flip-flop. So you have the selector thing, and then you have 1 input for each and 1 output for each. We have a clock and the selector. Program counter, 30-bit registers. You don't memorize anything of this. It's not memorizable. Yes, it was, and that's it. So that's all about this chapter. It's pretty small, and I give you only very tiny syllable for the test. I hope you will get like 100%. Any question?
I had a question.
Yeah.
Is stuff on assignment 3 gonna be on the midterm?
Say again?
Are questions on assignment 3, is that going to be on the midterm?
Yes.
Okay.
Maybe a short question. Yeah. Short question, maybe draw a truth table for XOR gate. Or draw a XOR gate or something like that.
Okay.
1 or 2 points, yeah. So it said like the you will have 10 questions. So maybe 1 or 2 or 3 maybe short questions. So one of them maybe from the logic gate. Any question with the logic gate? It's pretty simple, isn't it? So we learn how to use this. So all this thing is here, gates and plexer. We didn't use multiplexer to draw any complicated thing, but you can. Arithmetic, adder, subtractor, multiplier, divider, negator, lots of gates there. And I have the memory, D flip-flop, T flip-flop. We didn't go through those. Only D flip-flop is we're interested in. And then input, output, you can grab from that. Then I have the base, hook, edit tool, select tool, wearing tool, text tool, all that. And that analyzer is here when you analyze circuit. So you give them some input, some output by a truth table, and then it will create a circuit for you. It's pretty basic software. Should be more interesting, like we have a board in the lab and we build circuit using this stuff. So this is similar, so you can just feel it that you're doing some kind of practical here. If you're interested, you can go and learn more and design one of those complicated circuit that we have for arithmetic logic unit or something. And then it'll be more interesting. Anybody has any question or concern about midterm or keeping it very simple to the conversion and some short questions and some conversion from binary decimal to binary and hexadecimal to decimal, hexadecimal to binary, or binary decimal to hexadecimal, and some logic gate that in the end the truth table stuff, and then MIPS code to machine code to MIPS code. Pretty small syllabus. All you need to get familiar with the MIPS code a little bit, because I'm not giving you much question about, maybe you have a simple question, C code to machine code or MIPS code, maybe C code to MIPS code, a small one, simple. So you need to get familiar with the reference sheet, the MIPS reference sheet. Look at that. MIPS reference sheet, green sheet. That's one. Yeah, so you get familiar with this, they quickly can find things and then convert it, because you don't have a lot of time. So all this function code and opcode is here, and then all these operations are here. And they need to use this right side, this register name, number, use call condition, this one. And then for format, you need to follow this general format is this, the basic format, R and I. But the actual instruction here, when you get that set less than and sign SLTU, then you have to follow this RD first and then RS and RT. So that kind of thing. So you get familiar with this, familiar with this table and this table and that. And from conversion from MIPS code, machine code to MIPS code, you need to look at this part, because if it is binary or decimal or hexadecimal, you look at the binary for that, and that will be a machine code for that particular instruction. And I said, you don't need this on the right side, a lot of stuff. You don't need that. Any question? Everything clear?
Yeah, everything sounds good so far.
So simple. Yeah, I mean, it looks very simple, but when you come for the test, then you get confused. So the signed magnitude, and then 1's complement, 2's complement is, if I ask anything, I'll ask very simple stuff, but you have to be clear, like what is it? So the sign magnitude means if they mention anything in the question that this number is a sign magnitude number, then it will be in binary format. So the first digit will be for sign B, 0 for positive and 1 negative. And then the rest of the number is your actual number. If they ask you to convert to decimal or hexadecimal, whatever, you just do those, except the first bit. The first bit is for sign bit. And then 1's complement is the inverse number of that, whatever number is given to you. For example, they give you 1100, so that's 1's complement will be 0011, just inverse of that number. And then 2's complement will be add 1 to this 1 complement. That will be 0100. Because 011 is 2 basically. When you add 1 to it, it will become 3, 2, 4, 1, 1, 0. So the 1. Yeah, just add 1 to that, and that will be the 2's complement. We call it 2's complement. 1100 from the original number. Original numbers 2's complement will be that. You inverse that and then add 1, and that's. So now the tricky is probably like addition and the hexadecimal number. A lot of people get confused. So for the hexadecimal number, let me see if I can find my OneNote thing, because I didn't bring that. It is here, some of this. Yeah, it's the hexadecimal number. We practice this in the example as well. So when you get 16, the total, then you put 0 there and take 1 carry here. And you add that there, then add the whole thing. So in this case was 22, I think. So 16 plus 2, 16 plus 6 is 22. So you put the 6 there and take 1 carry for the next number. So 3 plus 7 is 4, 7 plus 4 is 11, 11 is B. So that's how you do this. We explain that. So that's hexadecimal addition. Hexadecimal subtraction is similar, will be similar format. So you take it as 16, 16 minus 2 will be 14. So 14 will be whatever digit 14 stands for is E. So E will be the result. And then if you D minus 8, so D is what, 13? So 13 minus 8 will be what, 5. So 5 will be the result. And then 3 minus 7, you cannot do that. So this will not work for the subtraction. So it has to be different numbers. Because you subtract from the larger number to smaller number. So this addition important for hexadecimal and binary addition as well. I will not give you multiplication or anything like that. No. Just addition, subtraction, binary addition for hexadecimal is important to understand. Any question? Oh, this opcode example here. So different thing.
For the overflow questions,
Yeah.
are you just looking for us to write down overflow, like if we notice, or do we have to go through the whole addition and subtraction?
An overflow may occur when you do the addition or subtraction. When you do that, it may occur, but it may not have it. If it is occur, the user say ignore this, just that. So here, the example of ones complement, twos complement. So if 1010, and then you reverse this, invert this number, 0101, that's one complement. And then you add 1 to it, 010, you add 1 to it, and that's twos complement. That's it.
Okay.
So when you do the addition, so let's say here, we have 0110, let's say we have 4 digits. But if it comes 5 digits, like if it says 1 here or something here, then you ignore that one. That's the overflow is. Because we're dealing with 4 digit. If it is appear more, then we ignore that. That's the overflow is. Nothing much. We learn about overflow more actually. We have the floating point number representation and learn a little more about the overflow stuff there, definition and all this. So I don't worry too much about those now. So here is another example. I think we had subtraction, binary subtraction. And you can check it. Like when you do this, you can check it. You convert this number to decimal and check it like what is the results. And then you can compare that your result is correct or wrong. Here, 1010 is 10, 0100 is 4. So 10 minus 4 should be 6. So if you do this, 0, 1, and 101 will be 1, and 0. So is this 6? Yes, it is. Then it's correct. So same thing here. Another one. 2 minus 1 is 1. So you can verify that. It is converting to decimal. So the binary addition, subtraction, and hexadecimal addition, it may cover in the test. Okay. Nothing else. So this is a hexadecimal number. When you see OX, meaning that hexadecimal number. Number may look like a decimal, but actually, if it is B there, then it's hexadecimal. Even if it is no B there, if 523, it says OX, that's hexadecimal. Because hexadecimal number starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So as long as they're there, any number within this range, that could be hexadecimal number if they say OX. And then you can convert it to decimal like this, using the 16 to the power 0 times first number, plus 16 to the power 1 times second number, plus 16 to the power 2 times third number, like this, if you have more. And then you work it out. Very clear? Sometimes they put a parenthesis and put 2, meaning this is a binary number. This 2 doesn't mean anything but that. Meaning it's a binary number. If we put 16, instead of OX, we put 5B3 and then parenthesis 16 in the bottom, that's hexadecimal, the same as OX 5B3. Remember that, that's also possible. You can write that way. Normally, like the normal number that we use every day, that's a decimal number. We don't put like parenthesis 10, but someone can do it. And we still should understand it as a mathematician, a computer scientist, that it is a decimal number, so it's base 10. Decimal number is base 10, so it's possible. Any question?
No questions at the moment.
So there's some workout. What is this for? For the larger number, I think let's check here chart for larger number. To the 12, to the 11, to the 10. If you have big number, splitting them and using this chart, you can do that too. Yeah. So that's an example of that, I think. Yeah, that's another chart. Yeah, here it showed that you put a parenthesis and put 10, this means this is a decimal number. When you're dealing with binary decimal, hexadecimal, it's better to have that because you may get confused. What is this number? Is it decimal or hexadecimal or binary? Your 10 is hexadecimal. Your 16 is hexadecimal. You put 8 is octal. Put 2 is a binary. Of course, binary number has to be 0 and 1, nothing else. Because binary have only 2, 0 and 1. But hexadecimal and decimal, they have more numbers. Hexadecimal, they have up to 15 numbers, 1 to F. The decimal numbers, they have up to 900, maybe more. Decimal numbers can be millions. So you keep this chart and use this. So that's there. That's another example for this 173, I think, conversion 156. Let's see, I think it's up there. And another example for 156, how do you do it? You split it in such a way, and you can use this chart, 128, 16 plus 8 plus 4, and put 1, 0, 0, 1, 1, 1. And whatever number you use, you put 1, and what you use, 0, 0. This is your binary number. That was that example, I think. And then we have this 156, converting. And I have this chart. 138, another number. How do you split it? 128 plus 2. And then I use this chart, give you a binary number. 140, you can split in this way. And then you can use this chart and convert it to binary. Okay, let's, for example, here 171, 162, 151, using this chart. Any question with this conversion stuff? Any question from the MIPS reference data? No question?
No questions.
Okay, cool. I think if you have no question, then and everybody should see that on iLearn we have this the assignment 3, a very simple one. Just do it, submit it whenever you can, and have the due date. I think you still have a lot of time to do that. So don't forget that. So it's an important assignment for you, easy assignment for Logisim, Logic Gate. And then we have one question from there. So whether you do the assignment now, then you can do your assignment, the test well for this chapter. So pretty much like 2 questions will be from kind of a theory, short questions, and other 8 will be doing some conversion. Okay, so practice more to speed up your writing because you have 75 minutes to do it. Because after that, I have another class, so I cannot continue. And that's the nature of midterm, okay? It's very important for your grade, of course. So focus on this. How much point I have? It's 20 points, I think, isn't it? Let's look at the syllabus one more time. syllabus 2021. Yeah, I think we put oh, actually we put midterm is 30%. 2020. 30%. So 3 each. So the 10 question, 3 each. So it's 30%. So it's very important for your grade. And you know the grading, you got to get 95 to get an A minus 90, B plus 86, B 83, B minus 80, C plus 76. Yeah, after that, those grades doesn't worth much because if you want to use that as a prerequisite, I think they need C plus or C. For the advanced course, you need a prerequisite for this, and you need to try to get better grades, okay? And then the way I said it, I mean, it's pretty easy to get a good grade if you focus what I say in the class. You should be fine. So it's 30%, so it's very important, okay? Don't miss the test, and you will have problem. You have to have medical background certificate to retake it. Otherwise, it's no excuse. Any question over anything at this point? Everyone is clear? What is expected?
I've got a quick question.
Sure.
Would there be an accommodation for people with disabilities?
What is that?
What would be the disability accommodation for people like for the midterm?
Sure. Sure.
I'm assuming like it'll be like we can submit it like last time, like submit it whenever we want, or whenever like as soon as possible.
Yeah, they can have some extended time. That's all it is. They allow to have some more time. Not like a whole day or something, not like that.
As soon as possible, like 1 hour, 2 hour. Yeah.
Yeah, it's like 75. So you get, everybody gets 75 minutes. They may get like 90 minutes, maybe 15 minutes more. That should be the norm, I think, or maybe 20 minutes more. That's what it is. Yeah, if you have any issues, just email me, and then I'll reply to that. When the exam happens, if you need more time, email me, anybody want to use that. Okay? But you need to have documentation. And I already have those letters from the DPRC. All right, so if you have no question, then I'll let you go for prepare your midterm. As I said, you need to practice, not just go to look at it. You need to practice by doing it. Then you will speed up your doing actual tests. So actual test is kind of stressful, and you need to turn on your camera all the time throughout the test. No excuses. If you don't have a camera, please borrow one or buy one or whatever. Buy another laptop borrow another laptop from somebody that has a camera on it. Something to log on to Zoom. All right. Okay, wish you all the best, and hopefully you get all 100% Wednesday.
Sounds good. Thank you.
Thank you. Bye-bye.